Good morning everyone, I am Mr. Ish. Thank you for joining me for this video. We'll have some exciting time doing this question over here, this system of linear equations involving three variables x, y, and z. When you're looking at it, reading from top bottom, you're seeing x plus y minus z equals 1, and then we have x minus 2y equals 0, and lastly we have y minus 2z equals 3. I want to do this question by means of matrix algebra. We can do this by substitution, but I think these type of questions are very well handled using matrices. Look at all the coefficients that apply to each of these linear equations and put them here in the means of a matrix. Looking right there at that very first one, we have 1, 1, minus 1, 1, 1, minus 1, and it's equal to 1. And you could read it across, x plus y minus z equals 1. Then when we're looking at the second one, we have a 1 minus 2. There's no z, so you put a 0, and then you have a 0. Last, there's no x, put a 0. Then you have a y with the coefficient of 1. There's a minus 2 and 3. X plus y minus z equals 1. X minus 2y equals 0. And y minus 2z equals 3. This is our system here in the form of a matrix. When you're looking at this, you're looking at a 3 by 3 matrix. That's what you have. There's an identity matrix for this specific form, 3 by 3, and it looks something like this: 1, 0, 0, 0, 1, 0, 0, 0, 1. You have to convert this part into this part. As a result of those changes, your values will come up here, x, y, z, which will represent the solutions of this system, x, y, z. As you manipulate the rows and the columns by means of calculations, you'll come up at this. This is what you want, have ones across in a diagonal format. These numbers will automatically manipulate themselves over a period of time and you'll get your answer. You want to start here with this number and get the zeros. Then you want to look at this number, make it into a 1, then look up and down and make those into zeros. Lastly, you want to look at this number, make it into a 1, and then work up and make everything 0. And that's how you would handle something like this. And we will sequentially do this question for you in this video. When I'm looking at this matrix, my very first item of interest is this 1 right over here. I want to get zeros down, so I'm going to come up with a rule. I'll do row 1 times minus 1 plus row 2. I'm ignoring row 3 because I already have a 0 here, so that's already done for me. When I do that, look what happens. The first row stays exactly as it is. The third row will stay exactly as it is because I'm not manipulating it, but the second row will change. 1 times minus 1 plus that 1 is a 0. 1 times minus 1 plus that minus 2 is a minus 3. And then minus 1 times minus 1 is a 1, plus 0 you get a 1, and you're getting the idea here, you'll get minus 1. So this is exactly what I wanted and I have it. Now look at it. I want to focus in on this number and convert this into a 1 because I want to have 1s across in a diagonal manner, and I'm going to do this row 2 divided by minus 3. When I'm doing this specific rule, I'm not doing anything with the first or the third rows. I'm only manipulating and affecting the second row. That's it. Now I'm going to divide the second row by this rule, everything by minus 3. You'll have a 0, 1, minus 1 over 3, and then you'll have a 1 over 3. Now I'm looking at this number and I want to get a 0 above it and I want to get a 0 below it. So I have to come up with two rules. I'll do row 2 times minus 1 plus row 1. It'll convert that into a 0. Then I'll do the same rule, row 2 times minus 1 but row 3, because I'll get that 0 over there for me, which is what I want. So I'll come down over here and I'll start doing this calculation. The row 2 will stay exactly as is. 0, 1, minus 1 over 3, and then 1 over 3. And now let's start manipulating the first and the third rows. I'll get a 1 over here. 1 times minus 1 plus that 1 is a 0. Minus 1 over 3 times minus 1 is a 1 over 3. Plus that, I'll get here minus 2 over 3. And then 1 over 3 times this minus 1 is a minus 1 over 3. Plus that 1 is a 2 over 3. Now let's look at the third row computation. This will stay 0. 1 times minus 1 plus that 1 is a 0. Minus 1 over 3 times minus 1 is a 1 over 3, positive 1 over 3. When you hit it with this minus 2, you're going to get here a minus 5 over 3. 1 over 3 times minus 1 is a minus 1 over 3, plus that 3, you know what you're getting over here, 8 over 3. Now, I've got my 1 here, my 1 here. The only thing that is missing here in terms of a 1 is this. So I'm going to do a rule over here to convert this minus 5 over 3 into a 1, and I'll hit it by its negative reciprocal. I'll do row 3 times minus 3 over 5. Minus 5 over 3 times minus 3 over 5 will make everything into a positive 1, which is what I want. I'll get here 0, 0, 1. I have an 8 over 3 over here, which is going to hit with this minus 3 over 5. These 3's will cancel out, but I'll get here a minus 8 over 5. By this specific rule here, row 1 and row 2 remained unaffected, so I can write them out. 0, 1, minus 1 over 3, 1 over 3, and then I have a 1, a 0, minus 2 over 3, and 2 over 3. Now this 1 over here is my item of interest, and I need to get zeros above it. And you see how close we are to the identity matrix, 1, 0, 0, 0, 1, 0, 0, 0, 1. That's exactly what we're doing. Now we need to come up with a bunch of rules to manipulate these and convert them. I'll do row 3 times 1 over 3 plus row 2. You'll get that 0 here. Then I'll do another rule. Row 3 times 2 over 3 plus row 1. You'll get that into a 0. So let's do that. When I do that, I'm going to bring everything right over here in a smaller condensed format. Row 3 is not being manipulated by any means, so we can do that. Write it out as is. 0, 0, 1 minus 8 over 5. Now you can easily, if you want, do these many of these calculations in your head. Let's look at this top rule. Row 3 times 103 plus row 2, that'll be a 0. This will be a 1. This will become a 0. Then you can do this. And for this part, you can actually bring out your calculator. Just do 8 divided by 5 minus. And then you're multiplying by 1 divided by 3, which is this right here. And then you're adding it to plus 1 divided by 3. And I'm getting a minus 0.2. I know minus 0.2 is a minus 1 over 5. Now let's do this last one rule right here. Row 3 times 2 over 3 plus row 1. When I do that, the numbers I'll get, as you're looking at this row, to affect that row, I'll get a 1, I'll get a 0, I'll get a 0. Then I'll do again on the calculator this last bit. I'll do 8 divided by 5 minus times 2 divided by 3 plus 2 divided by 3, and I'm getting a minus 0.4, which I know to be a minus 2 over 5. And there it is. I've got my identity matrix right here. This right here is my identity matrix, but I've got my solutions here for x, y, and z. And my solutions I'm going to put out for you right over here. Why don't I just put the solutions right here? In a good format, my solutions are minus 2 over 5, minus 1 over 5, and then minus 8 over 5. That right there represents the solution of this linear system having 3 variables. The variables, as you know, are x, y, and z. Now it remains for us to check that these solutions are actually good, and we will. But we'll run everything here using calculator strokes. I'm going to look at the first equation. I'll plug x, y, and z. I have a 2 divided by 5 minus, then I'll have plus 1 divided by 5 minus, then that minus 8 over 5 with that minus z will become a positive plus 8 divided by 5, and I'm getting a 1. Now let's look at this, x minus 2y. We'll utilize these two and we should get 0. I have a 2 divided by 5 minus plus 2 divided by 5. Minus 2 with that minus 1 over 5 became 2 over 5, so they cancel out, you got 0. Lastly, let's check this one. I'll utilize the y and the z variables. I have a 1 divided by 5 minus, then I have a minus 2 times that, which is going to give me a plus 16 over 5, plus 16 divided by 5, and I should get a 3, and I do. So in all of these cases, this system is good. It works out with that, that, and that. Our answer is minus 2 over 5, comma, minus 1 over 5, comma, minus 8 over 5. In some instances, you can just write these numerators and bring the fraction 1 over 5 outside the parentheses and do it that way. But you can leave your answer exactly as this and you would be right. This right here represents the solution of this system of 3 variables using matrix algebra. We have here our A matrix, which is our this part in terms of the coefficients. We have here our solution column. As you convert this into the identity matrix, which is 1 0 0 0 1 0 0 0 1, these diagonal ones is what you're aiming for. The solutions automatically come out by means of the steps x, y, and z. And that's it for this video. Hopefully you enjoyed it. Thank you for watching. Have a good day.